All right, so today we're going to be talking about Chapter 9, Lesson 4. This is about direct variation. So direct variation is very, very similar to slope-intercept form. The only difference is, in slope-intercept form, we have this. Direct variation is when b equals 0. It's a very special kind of slope-intercept form. What we're saying is the intercept is at 0, 0, right at the origin. So the overall equation would be y equals mx. Now in this case, this is slope. But when we talk about direct variation, this is also called the constant of variation. What it means is how x and y are related to each other. So if we want to find slope in this case, or m, we're going to go y divided by x. Just like we have been doing the entire time we have been trying to find slope. The nice thing here, though, is we're not really worrying about a change. We're really worried about the proportion between the output and the input. So, for example 1, it says determine if the relationship between distance in miles and the time in minutes is a direct variation. And then, of course, we want to explain. So, first of all, we can see that this does not cross at the origin. It crosses at 3, which means my y-intercept would be at 0, 3. We want 0, 0. So first of all, this is not a direct variation because it doesn't cross at the origin. But what we could also do is we can go, well, what's this ordered pair? Well, that'd be 15, 6. So 6 divided by 15 is the same as 2 over 5, which is 0.4. Let's also look at this one. This is going to be 30 and 9. You should see here that if we double the x, we should also be doubling the y, which we don't. But 9 over 30 is the same as 3 over 10, which is 0.3. If this were a direct variation, these two numbers should be exactly the same. In this case, they are not. So this is not a direct variation. We could say the proportion of y to x is not constant. We could also say that it doesn't cross at the origin. The y-intercept is not 0. If this is starting to kind of sound a little bit familiar, it should be, because direct variation is something we talked about with proportions and proportionality. One of the things we talked about when we had a graph of a proportion, 1, the line had to be straight, and 2, it had to be through the origin, which means that it has to have an intercept of 0, 0, which is direct variation. So direct variation and proportional graphs are the same thing. We call them something slightly different because when it comes to proportions, we're really looking at simply how the y and the x, the input and the output, relate to each other. With direct variation, we're talking about how they relate to each other. So, example 2. The equation y equals 45x represents the distance y in miles a driver can travel in x hours. Determine if there is a constant of variation, and if so, what does it represent in this situation? Well, there is one. The reason why is because there's nothing being added on or subtracted back here. This is a plus 0, which means that b is equal to 0, which means our intercept is at 0, 0, or the origin. So this is a direct variation. This number right here, this is our constant of variation. And what this number means, remember, our constant of variation is y over x. So if y is talking about distance in miles, so this is going to be distance in miles, x is talking about how far they can travel in x number of hours. So our constant of variation represents miles per hour. So really, they are driving 45 miles per hour. All right, so a few more examples here. Example 3, it says the depth of a hole varies directly. And what this means is a direct variation with the time spent digging the hole. It takes 10 minutes to dig a hole that is 8 inches deep. Write and solve an equation to find the depth of the hole after digging for 45 minutes. So, first of all, this is our direct variation equation. We want to have our slope, or our constant of variation, be y divided by x. So we're talking about 10 minutes to dig a hole that is 8 inches deep. It varies directly with the time spent, which means that our time spent is our input, and this is the depth of the hole. So time is going to be in the denominator. Depth is going to be in the numerator. So we have 8 inches for 10 minutes. And we want to, of course, simplify that. So we have 4 out of 5. Or we could say 0.8, whichever one. So our equation then would either be 4/5 x or y equals 0.8x. Either are perfectly fine. We now want to find out how deep we can dig the hole after 45 minutes. So we would either use this equation here and use 45 as our input, or we can use this equation here and still use 45 as our input. As we go through this, 4/5 times 45, we would have 36. Same thing here, 36. And our units would be inches, because that's what we had up here, inches per minute. And if we're going for 45 minutes, this number should be dealing with inches. So after 45 minutes, the hole would be 36 inches deep. There. After 45 minutes, the hole would be 45 inches deep. Now, when it comes to having direct variation and constants of variation, we can actually compare two different constants to see which one is going to be better for us. And really, when you go to the store, what you're actually looking at is like price per ounce. The lower the price per ounce, the cheaper it is. Those are direct variation. Now, in this example, it says the equation y equals 3.5x, I'm going to circle that because that's important, represents the relationship between the total cost of y of ringtones and the number of ringtones X purchased from a company called PhoneMix. The graph shows the cost from Ringtones Plus. So which site charges more for ringtones? And then, of course, explain. So PhoneMix, which is y equals 3.5x. So they charge, again, here is my constant of variation. So $3.50 per ringtone. The reason why I know that is because Y is the cost, X is the ringtones purchased. So we want to have dollars per ringtone. Now, for the equation, I need to come up with a slope. So I can pick 2 points. Let's just go here. So I have 1, 3. Here I can also look at 2, 6. If this is a direct variation, and it looks like it is because it's a straight line that goes to the origin, I should simply be able to do y divided by x, which would be 3 over 1. This one here would be 6 over 2, which also simplifies to 3 over 1. And what this slope represents is $3 per ringtone. So now I have this one from Ringtones Plus and this one from PhoneMix. So it's pretty clear to see that PhoneMix charges more for ringtones because $3.50 per ringtone is more than $3 per ringtone. So PhoneMix charges more. For ringtones. Than Ringtones Plus does. Because $3.50 per ringtone is more, and we were looking for more, than $3 per ringtone. All right, that's going to be the end of lesson 4. If you have any questions, please let me know.